Hello students, today we are going to discuss the chapter circles for class 10th, and I'm going to start it with the introduction of few terms. Firstly, center. This is the center of the circle. When we draw a circle, we put the needle of compass and then we draw it. So where the point where we put the needle of compass is called the center of the circle. Radius. Any line joining the center to the circumference. Any line joining the center to the circumference. That we do not have a single line which is called radius. There can be unlimited of these type. For example, this is also a radius. This is also a radius. Now I use the word circumference. So this is the circumference. The boundaries of the circle is circumference. So this is the circumference. This is radius. Now the diameter. If we draw a line which passes through the center and cut the circumference at 2 points is called diameter. Like radius, we can have unlimited diameters, because if I take this point and I draw a line which passes through center and end it to circumference again, then this particular line is called diameter. If diameter is d and radius is r, then our diameter is twice of radius. We can say radius is half of diameter. This we have already studied in class 9. If we draw a line inside the circle which joins 2 points on the circumference, this is called chord. Now the question can be arised in mind that is diameter a chord? Yes. Diameter is the longest chord of a circle. So arc is any part of circumference. For example, this. If I take any part on the circumference of the circle, then this particular part of circumference is called arc. Now sector. I have taken this arc. If I join ending points of the arc to the center of the circle, then this particular part is called sector. This remaining part is also sector. This is called minor one. This is minor sector of this arc. And this remaining one is the major sector of this arc. Now segment. If I take any 2 points, I'm not talking about arc. Now I'm just taking a chord. Chord is also dividing the circle in 2 parts, not equal but 2 parts. So this part is called major segment and this part is called minor segment. So that means when we discuss the part of circle which we get because of some arc, we call it sector, and when we discuss about the part or sections of circle which we get because of a chord, that is called segment. Right? Major, minor. Now let's discuss some more terms. Lines and circle, which is the part of your syllabus in class 10th now. So let's discuss about the lines related to a circle. Suppose I draw a line here. This line has no relation with this circle because this is not even touching anywhere. So these type of line which which do not touch the circle anywhere are called non-intersecting, because this line is not intersecting the circle anywhere. Now if I take a line which passes through the circle and intersect at 2 points, right? It intersects the circumference at 2 points, then this particular line is called secant. Secant is the line which is an intersecting line of a circle and cuts the circumference at 2 points. Now comes another one which touch the circle at 1 point only, right? It touches the circle at 1 point. So that particular type of line is called tangent, right? This type of line has no connection with circle, non-intersecting line. We will not be studying any type of theorems related to non-intersecting lines. But yes, if we have secant line, if we have tangents, we are going to study some theorems about tangents and secant. Let's start with the theorem 10.1. That is, the tangent at any point of a circle is perpendicular to the radius through the point of contact. What exactly they are saying? Let's draw first the tangent at any point of a circle. Let's draw a tangent first. Okay. The tangent at any point, this is the point of a circle, is perpendicular to the radius. Perpendicular to the radius through the point of contact. This is the point of contact. So through this point of contact we have to draw a radius, and we have to prove that this particular radius is perpendicular to this tangent, or we can say reverse, that this particular tangent is perpendicular to this radius, right? So we have to prove it. It's a very simple theorem. Understand the concept of perpendicular first. This theorem is based on a very simple concept of perpendicular which we learned in class 9th. What we have studied about perpendicular, what exactly a perpendicular is. If through a point I want to draw a perpendicular here, if I draw a perpendicular from this point to this line, then perpendicular is the shortest distance between this point and this line. That means if I draw other lines through the same point to the line on which I have to draw the perpendicular, then this line, if it is shortest distance between this point and this line, then this particular line is the perpendicular to this line from this particular point. Here I can prove that the distance between the center of the circle and this tangent, if this distance is the shortest one, then it is perpendicular on this line. So for that, to compare, I have to take other lines also. Let's take other lines. So it's very simple to understand that suppose I am taking this line, this one, that suppose N is this particular point where this line is intersecting the circumference. So ON is less than OQ. Why? Because ON is the radius of the circle, and here we are increasing the radius, so that means OQ is obviously greater than ON. Suppose I am taking another line and I'm giving this name N1 and Q1. Then here also ON1 is always less than OQ1, right? With the same concept that ON1 is the radius and ON1 plus N1Q1 is OQ1. So obviously OQ1 is greater than ON1. Now ON1 and we can take many of them, they all are equal to ON, ON1 and so on must be equal to OP. Why? Because these all are radius of circle. So that means radius of circle is always the shortest distance between the center of the circle and the tangent. And if it is the shortest distance, then OP is perpendicular to the tangent, or we can say tangent is perpendicular to radius. Which radius? Which passes through the point of contact. Not that much of calculation, it's just a simple concept of perpendicular. If we remember from class 9 what a perpendicular is, then it is very simple to explain it. I hope it is clear. Now we'll discuss about points and circle, which is very much there in your class 10 NCERT book. So case 1 is there that there is no tangent to the circle passing through a point lying inside the circle. See, we have already studied about what exactly a tangent is. That for a tangent, the point is supposed to be there on circumference only. Why we are saying it? Because if we take any point inside the circle, and if we want to draw a line, it will touch or intersect the circle at 2 points, which will not satisfy the definition of tangent, because tangent is a line which touches the circle at one particular point. It is just a secant, it is a secant or an intersecting line, but not a tangent. So we can say that there is no tangent to the circle passing through a point lying inside the circle. Now next one says that there is one and only one tangent to a circle passing through a point lying on the circle. Let's take the point, and what they are saying that there is one and only one and only one tangent, because if I would try to draw other lines, that line will cut the circle at 2 points. If I want to draw another line, it will overlap this line only, right? And please do not get confused, they are not saying that there is only one tangent for the entire circle. There can be many tangents, but what they are saying that for a particular point there is only one tangent. If you want to draw another tangent, you have to take other points, and you can draw as many as you want, right? So there can be many tangents to a circle, but for a particular point there is only one tangent. Now next case is there are exactly two tangents to a circle through a point lying outside the circle. In this case, point was lying on the circle, but in this case they are saying that point is outside the circle. So the line passing through this point is not the tangent, but they are saying that from this point, if I want to draw a tangent, it can be like this. And if I want to draw one more, yes, I can draw Yes, I can draw. But if I want the third one, it will pass through this and cut the circumference at another point. Let me draw one for you. For example, if I want to draw third one, then it will cut the circumference at another point also. So it is cutting the circumference at 2 points. That is why it is not a tangent. So from any external point we can draw only two tangents. We have to understand this very carefully because our next theorem is based on this fact only. So now this is the next theorem, which says that the lengths of the tangents drawn from an external point to a circle are equal. In the last case, we saw that from the external point we can draw only two tangents, and the other one so what additional they are saying is that we know that from external point we can draw only two tangents, but now they are saying these two tangents are always equal. So there are two ways of solving it. I am going to tell you with both the ways. First is congruency. How? What we'll do is we will join these lines, which are actually the radius of the circle, and this also. If we can prove that these triangles are congruent, then by CPCT we can easily prove that this is equal to this. Now we'll take these two triangles. In both the triangles you can see that this PO is common, right? So in these two triangles PO is equal to PO because it is common. In these two triangles, and OQ is equal to OR. OQ is equal to OR because it is what? Radius. And by last theorem we studied is that the radius of the circle is perpendicular to the tangent at the point of contact. So this is also 90. This is also 90. So that means angle Q is equal to angle R, which is equal to 90. So by RHS we can say angle POQ is congruent to POR, and by CPCT we can say PQ should be equal to PR. So hence proved. This is what we were supposed to prove. So this was the first method. By congruency we proved this theorem. Now by Pythagoras also we can prove the same. In triangle this and this, because we know that this is 90 degrees. So in this PO square, by Pythagoras theorem, PO square in triangle POQ, PO square is equal to OQ square plus PQ square. And in this triangle again PO square is equal to OR square plus PR square, right? And because these two both are PO, so that means this is equal to this. So we can write OQ square plus PQ square is equal to this, OR square plus PR square. Now we know OQ is equal to OR being radius. So OQ square plus PQ square is equal to, that means I can write OQ in place of OR. So OQ square plus PR square. By cancelling it, we can say PQ square is equal to PR square, which implies PQ is equal to PR. This is what we wanted to prove, that the length of the tangents drawn from an external point to the circle are equal. I hope you understood both the methods. So this was the introduction of this chapter. In next video, I'll take the exercise of the same chapter. It's a very small chapter. We'll cover it within 2-3 videos very soon. I hope it was helpful. Thank you for watching.